class. Hello class, today we are going to continue talking about how do we operate polynomials. Last class we have covered how do we apply both horizontal method and vertical method to add up two polynomials. And today we're going to continue talking about operating polynomials. Number 15 is about subtracting polynomials. Take the difference of two polynomials. We also have two methods for subtracting polynomials. Before we give the two methods, I want to clarify some misunderstanding. Firstly, we need to know subtraction, unlike addition and multiplication, subtraction is not commutative. Means if we have two numbers a and b, a minus b in general is different from b minus a. For example, 8 minus 5 equals 3. If we switch the two numbers in the subtraction, we do not have the same number. Instead, we have the opposite of 3. Addition has commutative property. If we add a plus 5 or switch the order of 5 and 8 in the addition, 5 plus 8, they both equal to 13. But in a subtraction, we cannot just randomly switch the order of the two numbers because the order of the two numbers does make a difference. As you can see, 8 minus 5 is 3. If we interchange the order of the two numbers, we get the opposite. So be aware of that. We cannot just randomly switch the order of the two numbers in a subtraction. Another thing, if we say the difference between quantity A and quantity B, the difference between A and B refers to A minus B, not B minus A. If you ever see a description like that, the difference between A and B, knowing that's a subtraction, and it has to be A minus B, not the other way around. Whatever you see first, go first, and then minus the second number you see. And if we say subtract A from B, subtract A from B refers to, how about you help me to answer this question. When we say subtract A from B, this is two different things, okay? We are done with this part. Now we are talking about considering subtract quantity A from quantity B. My question here is, when we say subtract A from B, do we mean A minus B or B minus A? Subtract A from B. Subtract A from B. Oh, I'm muted. Actually, that's why I don't hear the notification of the chat. Oh, actually nobody. Oh, okay, sorry. B minus A. Joe says it's supposed to be B minus A. Exactly. That's correct. Subtract A from B. For example, you have $10 and you go buy a sandwich. It takes $5. So the cashier take away $5 from $10. So your leftover would be, the money you have right now would be 10 minus 5, not 5 minus 10. Okay, so now let's start question number 15. How do we use the horizontal method? Let's do the horizontal method first. We are looking at two polynomials here. We are going to subtract this blue polynomial from this pink polynomial. Let's see, how do we find the difference? We are subtract the green polynomial from the pink polynomial. Subtract A from B. So using horizontal method to process difference of two polynomials, this is what you do. Do parentheses. Parentheses minus parentheses. Okay, please. When we process subtraction, I would recommend that you use parentheses. One polynomial minus another polynomial. So here, subtract green from pink. So we should have pink in the first polynomial and the green in the second polynomial. So we should have 10z plus 8 in the first polynomial, and then we have 6z plus 6 in the second polynomial. All right, and then we remove the parentheses. Question: what's the coefficient of the parentheses that frame the pink polynomial? To remove parentheses, we apply the distributive property, right? To apply the distributive property, we need to know what to distribute. The thing we need to distribute is the coefficient of the parentheses. Look at the pink, the parentheses that frame the pink. What's the coefficient? What's the coefficient of the pink? 1, awesome. Exactly. Correct. We have 1 here. And what's the coefficient of the parentheses that frame the green polynomial? The green one. When we distribute, what's the coefficient of the green parentheses? -1, right? Thank you, Joe. Exactly. Perfect. Thank you, Amanda. It is -1. So -1 here. Very good. So when we have 1 as the coefficient, we could literally remove the parentheses because 1 is the multiplicative identity. 1 multiply anything is just a thing. So we could literally, that's the only case in which we can literally remove the parentheses. So we can get rid of the parentheses as free 10z plus 8. 1 times 10z is 10z. 1 times 8 is 8. Now we are going to remove the second parentheses. We agree the coefficient of the second parentheses is -1. So -1 times 6z, -6z. -1 times 6, -6. When the coefficient of a parenthesis is negative, we remove the parentheses and change each member in the parentheses to their opposite. That's the reason 6z becomes -6z, 6 becomes -6. And everything, all the terms now are free. No parentheses, no grouping symbol. They are free for us to combine them. Do we have like terms? Very obvious, 10z and -6z are like terms. 8 and -6 are like terms. So we can combine them. 10z minus 6z, 4z. 8 minus 6, 2. So the answer is 4z plus 2. 4z plus 2. Right? Very good. Thank you, Amanda. So that's how do we apply the horizontal method to subtract a polynomial from the other polynomial. What we need to pay attention are two things. The first thing, you need to be certain that you are using the right polynomial to subtract another. I mean the order of the two polynomials. In this case, we use the pink to minus the green. The other thing, the second thing is use the parentheses. Use the parentheses to frame the two polynomials in the subtraction, and then apply the distributive property to remove the parentheses. There's a benefit of doing that. Without the parentheses, you very likely mess up the sign. So I strongly recommend use the parentheses. Now let's see, how do we use the vertical method to take the difference of two polynomials. Second method, vertical method. Vertical method is the same. We still have to figure out which polynomial minus which polynomial, right? For the vertical method, since we are using pink to minus green, so we're going to put a pink on the top, green on the bottom. Green is on the bottom, pink is on the top. Okay. We have a pink, which is 10z plus 8. We're going to change the minus sign in red, minus the green polynomial, which is 6z plus 6. And then I want you to do this. Do what? I want you to do keep, change. What is the keep, change? I want you to keep the polynomial on the top, which is 10z plus 8. Keep the top polynomial. Change the minus sign as addition sign. And change the green polynomial to its opposite. Change the green polynomial to its opposite. -6z minus 6. This way, we convert subtracting polynomials vertically to adding polynomials vertically. Adding polynomials vertically is pretty convenient, as long as you make sure the vertically aligned terms are like terms. So here we have the alignment taken care of. The first column, 10z, 96z, they are like terms. The second column, 8 and 96, they are like terms. Okay, 10z and 96z, they add up to 4z. 8 and 96, they add up to 2. So the answer is 4z plus 2. Same with earlier. This question pretty straightforward, not very challenging. The purpose of demonstrating the two methods is to show you common mistake that we try to avoid. The common mistake for the vertical method is the alignment, also the sign. So I would recommend that you do keep, change. Keep the first polynomial on the top, change the subtraction to addition, and then change the second polynomial, the bottom polynomial, to its opposite. And then you add up the vertically aligned like terms to get the result. Let me know, do you have any questions? We will have a problem to practice later when we look at Pearson. All right, very good. Then we covered addition, and we also covered subtraction. Now we are going to talk about multiplication. We are going to talk about multiplication. How do we multiply polynomials? In the past, actually, before last semester, I use multiple methods when it comes to multiplying polynomials. And today, I think I will show you the multiple methods, but mainly we're going to settle with one method only. All right? We are going to settle with one method only. And let me firstly add one question here. Missing one question. 93x squared times 5x cubed. Okay. So the first question is about multiplying two monomials. Guys, do you still remember the definition of a monomial we learned on Monday? What does a monomial look like? This is a univariate monomial, right? A univariate monomial has three parts. A here is the coefficient. That number, that's a constant. That constant could be any real number. Second part is the variable base. Third part is the exponent on the shoulder of the variable base. And the exponent, the degree here, has to be whole number. That's a monomial. So when we talk about multiplying polynomials, we start from multiplying two monomials. Let's look at here. How do we multiply two monomials? It's pretty straightforward. When we multiply two monomials, we multiply their corresponding parts. Monomials are also terms, so they have two parts. Numerical part, that's the coefficient, and variable part. So here, what I'm talking about is we are going to multiply their corresponding part, multiply the coefficient, and then multiply the variable part. 93 times 5, x squared times x cubed. 93 times 5 is negative 15. Question, what is x squared times x cubed? What is x squared times x cubed? Perfect. X fifth. What's the name of the rule we could apply to get that result, x to the power fifth? What's the name of it? That's the first formula we learned, right? What is that called? It's called the product rule, right? When we multiply two exponential expressions with the same base, we keep the base and add up the two powers, the two exponents. 2 plus 3 is 5. And that's it. Very straightforward. I believe you can do it, right? That's how do we multiply two monomials. That is, how do we multiply two monomials? Again, why do we have x to the power fifth? It's because we have 2x multiplied together from x squared. And we have 3x multiplied together from the x cubed. So together we have 5 x's, and that is x to the power fifth, right? Okay, that's the first question. How do we multiply two monomials? Next question, how do we multiply a monomial by a polynomial? The polynomial is not a monomial. Let's look at this question. The monomial is 9x squared. It is multiplying by a polynomial with 1, 2, 3, 3 terms. So this is an example monomial times trinomial. Earlier we have a monomial times monomial. This is a monomial times trinomial. Well, any other types of polynomial would all be the same process. When we multiply a monomial by a trinomial, we see the monomial as the coefficient, and then we apply the distributive property. Let me say it again. When we multiply a monomial by a polynomial, which is not a monomial, we see the monomial as the coefficient, and then apply the distributive property. So in this case, we are going to distribute 9x squared to each member in the parentheses. In the parentheses, we have a trinomial, so we have 3 terms. We're going to multiply the pink with the first term, plus the pink times the second term, plus the pink times the third term. So we have 9x squared times 97x cubed plus 9x squared times ax plus 9x squared times -9. Distributive property. What are we distributing? We're distributing the monomial. The monomial is 9x squared. Multiply with the first term in the trinomial plus the pink times the second term plus the pink times the third term. Okay. And then we are going to simplify. In this expression, we have 3 parts, and they are adding together, right? It's the first part, second part, third part. And each part is a multiplication of 2 monomials. That's what we have just covered earlier. Okay, let's see. 9x squared times 97x cubed. By the way, this is not 9x squared minus 7x cubed, okay? With the parentheses, the structure is different. We have the multiplication of 9x squared and 97x cubed. So how do we multiply them together? Remember, multiply their corresponding parts. Let's deal with the numerical part first. 9 times 97. Please don't get a 2. We are not subtracting. 9 multiplied by 97, negative 63. And then x squared times x cubed, x fifth. Square here has 2 x's. Cube here has 3 x's. Together 5. And then next part, 9x squared times 8x. 9 times 8, 72. Variable part, x squared times x. We have 2 x's multiplied together from the square, x squared. And then we have 1 x here. So together we have 3 x's. So we have x cubed. And the last part, determine the sign first. Again, this is not 9x squared minus 9. This is 9x squared times 99. Positive times negative gives us negative. Negative 9 times 9, we have 81. And we only have x squared as the variable part. So just keep it down. Copy it, x squared. And that's the result. Negative 81 x squared. Very good, very good. You guys are doing great. Turns out monomial times monomial is something we have to always do when we multiply polynomials in general. Like this monomial times trinomial is equal to the monomial times each term. Those terms are monomials as well in the trinomial. So in the 3 parts, we still have to multiply the monomials together. Okay, let me know, do you have any questions about this problem? A monomial times a trinomial. If it's a monomial times a binomial, that will be the same, right? The process would be the same. You just need to distribute the monomial to each member in the binomial. If we are multiplying a monomial by a polynomial with 4 terms, then you just need to multiply the monomial with each member of all the 4 terms in the parentheses. And that's how do we do it. And next question, I'm going to demonstrate how do we multiply binomial with binomial. How do we multiply 2 binomials together? Binomial times binomial. This is the place I have actually how many methods? 6 methods. I'm going to show you those 6 methods, okay? Binomial times binomial. First method, FOIL. Method 1, FOIL. Kind of like in this country, we have to explain what is a FOIL because it's so famous. If you don't know what is a FOIL in algebra, it seems like it doesn't make sense. Like you already taken the algebra class. We use FOIL is a technique to multiply two binomials, and FOIL they represent F here stands for first. O here stands for outside. I here stands for inside. L here stands for last. FOIL is the initial of the 4 words. And let me explain how do we apply FOIL, this technique, to multiply two binomials. Okay. Let's start it. 4x minus 3 times 5x plus 1. So firstly, you need to see the 4 terms in the expression, right? We're looking at a product. This expression is a product, 2 binomials multiplied together. You should see the 4 terms. The first term is 4x. I colored it in pink. Second term is the blue, which is 93. Third term is the yellow, 5x. Fourth term is the green, positive 1. So first we should see the 4 terms. And first represent the pink and the yellow. Why? Because the pink is the first term in the first parentheses, and the yellow is the first term in the second parentheses. So when we say first, we are referring to those 2 terms. Outside, we have 4 terms, right? The pink and the green, they are on the outside. So FOIL outside refer to those 2 terms on the outside, 4x and 1, the pink and the green. Then we know what are the 2 inside terms. Inside refer to 93 and 5x, the blue and the yellow. They are on the inside. Last terms, last means the blue and the green. Because the blue term is the second term or the last term in the first parentheses, and the green is the last term in the second parentheses. So to apply FOIL, my method to apply FOIL, if you really want to use this method, and you do what I do here, you do what I'm going to do here. First times first plus outside times outside plus inside times inside plus last times last. First times first, outside times outside, inside times inside, last times last. Set up the structure first. This is an addition of 1, 2, 3, 4 parts. So we have 3 addition symbols. And each part is a product of 2 terms. First times first, we have pink times yellow. So 4x, get a structure set up, and then fill in those blanks. You should have 8 blanks to fill. So first is the pink times yellow. Pink times yellow, 4x times 5x. And then outside times outside, pink times green, 4x. Times inside, blue times yellow, negative 3 times 5x. Last times last, blue times green, negative 3 times 1. I think everybody can do that. Just follow the correct process. Get a structure set up, and then put terms in the right spot. And then next step, you simplify. Try not to do multiple steps in one, and you will mess up the procedure, and you'll probably end up with the wrong answer, especially when you are a beginner. First step is to set up the structure. Second step is only fill in those blanks. Be careful with the sign. And next step, we simplify. The first part, 4x times 5x. 4 times 5 is 20. X times x, x squared. X times x, x squared. Second part, outside times outside. 4x times 1 is 4x. Inside times inside. 93 times 5x, negative 15x. Last times last, 93 times 1, we have 93. All right, that's how do we simplify each part in the expansion. The last step is to look at the result and then combine like terms if there are any. Do we have any like terms here? 20x squared, 4x, negative 15x, 93. The two terms in the middle, they are like terms, right? We're able to combine them. So we have 20x squared, 4x minus 15x, you know it's negative 11x, right? Negative 11x, very good. Negative 11x, and then minus 3. And that's the result. FOIL. This technique, this method is called a FOIL. FOIL is like when you're baking, when your mom baking the paper, shiny paper, is a FOIL. It stands for first, outside, inside, last. The procedure is to set up the structure for FOIL first. The expansion should have 4 parts added together. Each part has 2 parentheses multiplied together. And the 4 parts are first times first, outside times outside, inside times inside, last times last. That's the first step. Second step, you place those terms in the right spot to fill in the 8 blanks. Be very careful with the sign. The blue term is negative, so you would have to carry the negative sign with it. Third step is to simplify each part. And the last step is to combine like terms if there are any. Any question about FOIL? Any question about FOIL? I'm recording, so if you want to look at it again, you can just always go to the recording. Thank you, Jill. And that's the first method. Second method. Method number 2. Let's see what I do for the second method. I'm going to do repeated distribution. Repeated distribution method. And this method actually is the method I learned when I was little. 4x minus 3 times 5x plus 1. Repeated distribution method. So what happened is we are going to do this. Firstly, distribute the first term in the first parentheses to the 2 members in the second parentheses. And then we distribute the second member in the first parentheses to the 2 terms in the second parentheses. Let me do it again, okay? Let me rewrite this actually. Keep some space above it. 4x minus 3 times 5x plus 1. Repeated distribution is we distribute the first term to the 2 terms in the parentheses in the second parenthesis first. 1, 2. And then repeat the distribution. And then we are going to distribute the second term in the first parenthesis. 1, 2. So we are going to have 4 terms in the expansion, multiplication expansion. So here, 4x times 5x plus, let me demonstrate again, 4x times 5x, and then we have 4x times 1. And then we have, or not done yet, by the way. Let me move this. And then we have 93 times 5x. And then we have 93 times 1. Repeated distribution. When we multiply a monomial by a polynomial, we just distribute the monomial, right? But if we are multiplying 2 binomials, then we just need to repeat the process. Distribute the 2 terms in 2 rounds. The first round, distribute the first term. In the second round, distribute the second term. We have 4 terms in the expansion. Let's simplify each term. 4x times 5x, 20x squared. At this point, you should know how do you simplify, how do we multiply 2 monomials. Yeah, how do you have x squared instead of 9x? We do not have 9x, by the way, because we are not adding 4x and 5x. We are multiplying them. 4 times 5 is 20. X times x gives x squared. 4x times 1 is 4x. 93 times 5x, 15x. 93 times 1, 93. And then you combine like terms, x, 20x squared minus 11x minus 3. That's the second method. Repeated distribution method. Repeated distribution method. That's the second method. Let me see. The second method. Now we are going to talk about the third method. The third method is the vertical method. So we are going to vertically align the 2 binomials. One on the top, the other on the bottom. 4x minus 3 times 5x plus 1. We align them like this, align them vertically. Similar with multiplying 2 numbers. So we are going to firstly multiply this 1 to the binomial on the top. So 1 times 93 is 93. 1 times 4x is 4x. And then we are going to multiply this 5x with the binomial on top of it. So we have 5x times 93, 5x times 93, which is negative 15x. You put a 0 here. Remember, when you multiply 2 numbers, same thing, right? 5x times 93, negative 15x. 5x times 4x, 20x squared. And now, you always make sure vertically aligned terms are like terms. And you add them up. You have 20x squared negative 4x minus 15x, negative 11x, negative 3 plus 0, negative 3. So that's the vertical method. Very close, very similar with when you multiply two numbers. For example, 12 times 34. 4 times 2 is 8, 4 times 1 is 4, and 3 times 2 is 6. You put a 0 here, right? 3 times 1 is 3, and then you add them up. 8, 4 plus 6 is 10, 408. Very similar with that. So that's the third method, vertical method. I thought I have, oh, okay. So method number 4. I learned this method from a student. Pretty cool. It's called George method. We have 4x minus 3 times 5x plus 1. So what happened is we're going to draw in a picture, drawing something. This is first times first, that's the, we have first times first, and then we have last times last. And we have inside times inside, we have outside times outside. And this is a boy whose name is George, and George is smiling at you. So George method. Let's see, how do we apply the George method? So left eyebrow, George's left eyebrow is 4x times 5x, 20x squared. Right eyebrow, 93 times 1, 93. His mouth or nose, I don't really know what is exactly. Is this mouth or nose? 93 times 5x, negative 15x. And then 4x, the chin of the boy. The chin of the boy is 4x times 1, so 4x. And we combine like terms. 20x squared minus 3, negative 15x plus 4x, negative 11x. The result is the same with earlier. It's just this, the order of the terms is different. You can switch the order because of the commutative property. You would have the same thing, 20x squared minus 11x minus 3. That's the fourth method. It's called George. Do I have 5 methods, not 6? Okay, the last method, method number 5, is the box method. Method number 5, box method. I also learned this method from this country, and I learned a repeat distribution method. And the box method is really, really good method. So let me show you how. And we are going to use the box method for the rest of the practice. We are multiplying 4x minus 3 with 5x plus 1. We're multiplying 4x minus 3 with 5x plus 1 using the box method. So firstly, the first polynomial is binomial. The second polynomial is also binomial. Because of that, we know we are going to create a box. The box has 4 cells, 2 by 2. Since this is binomial times binomial, we're going to have a 2 by 2 box. 2 by 2 box. 2 by 2 box. This is the box I'm talking about. Okay, I'm going to place the 2 terms in the first binomial vertically. 4x is the first term, negative 3 is the second term on the left. And then I'm going to place the 2 terms in the second binomial on the top of the box. 5x and 1. Okay, so we're gonna make a 2 by 2 box. 2 by 2 box, and write the 2 terms in the first binomial on the left, and write the 2 terms in the second binomial on the top of the box. And then we are going to multiply. In this cell, in the pink, I'm changing the color. The blue here. In the blue cell, we are going to, the blue cell is the first row and the first column, right? And in the blue cell, we are going to have the multiplication of 4x and 5x. As you can see, the blue is the intersection of 4x and 5x. Multiply 4x and 5x together, we have 20x squared here. All right? And then the yellow. The yellow cell is row 1, column 2. Row 1, 4x, column 2, 1. So the yellow gonna have the multiplication of 4x and 1. 4x times 1 is 4x. And then we're gonna use another yellow, okay? This yellow is row 2, column 1. So 93 times 5x. 93 times 5x is 15x. And then I'm going to color the last cell as green. The green cell is column 2, row 2, column 2. So we have 93 times 1. 93 times 1 is 93. As you can see, the two yellow on the diagonal of the box, the two yellow are like terms, right? The two yellows are like terms, so we can combine them. So normally I do this. Let me change the color. This is the blue. So the blue, yellow, green. So from the blue, we have 20x squared. From the yellow, we have 4x and then 15x, then 11x. From the green, we have 93. And that's the result. You just need to add up the 4 terms in the 4 cells of the box. Add them all up. And the pattern always, you will always see a pattern like this, like a diagonal pattern. The blue gives us the first term. The two yellows are like terms. Combine them gives us the second term of the product. And then the green gives us the constant term. Any questions about the box method? Do you like the box method? Very useful. The box method. Am I clear about the demonstration? Yeah, we are going to practice more. Okay, so that's the binomial times binomial. I remember I have 6 methods, but now I only remember 5. I'm going to only use a method of 5, box method in the future, okay? And the box method also apply to other types of multiplication of polynomials. For example, this question. This problem. This problem is a trinomial times a binomial. Trinomial times a binomial. I'm going to use the box method to find the product of the trinomial and the binomial. Trinomial has 3 terms. Binomial has 2 terms. So that means we are going to create a box. Create a box 3 by 2 or 2 by 3. So if it's 3 by 2, the box looks like this. If it's 2 by 3, the box looks like this. I would recommend you always create a box that is more stable. If you have two things, like definitely the first one is more stable, right? Because it's flat, and the vertical one is easier to fall. So I would recommend that you always do the flat box. So we are going to do a 2x3. We are going to do a 2x3 box. Really doesn't matter because the order of the two polynomials in the product does not change the result. Just for comfort, I feel more comfortable doing a flat box consider with a falling box. So this is a 2x3 box. Is more stable. So I'm going to put, since it is 2x3, I'm going to place the binomial, the two terms in the binomial on the left side, to the left side of the box, x minus 3. First term x, second term negative 3. And it has three columns, so on above, on top of the box, I'm going to place the three terms in a trinomial. X squared, negative x, positive 2. All right? Trinomial, the three terms in the trinomial go on top of the box. The two terms in the binomial go to the side of the box. And then let's multiply. Do it here first. X times x squared. Tell me, what do we have? X times x squared. X cubed. Perfect. Let me write it down. X cubed. And then we do here. Tell me, please, what do we have in row 1, column 2? X times negative x. Always multiply because we are multiplying two polynomials. And you don't have 0, guys. Negative x squared. Very good. Negative x squared. Perfect. Let me write it down. Negative x squared. And what do we have here? Row 1, column 3, x times 2. 2x. Very good. Let me write it down. 2x here. 2x here. Okay, and what's going to be here? Row 2, column 1. Negative 3x squared. Perfect. Negative 3x squared. And what's going to be here? Row 2, column 2. Be careful with the sign. Positive 3x squared. Awesome. Negative, oh, hold on. Row 2, column 2, my bad. Row 2, column 2 is negative 3 times negative x. Be careful. Negative 3 times negative x. What should we have? Positive? Yeah, just 3x. Awesome. Just the 3x. Very good. Just the 3x. And what's going to be here? Row 2, column 3. Negative 3 times 2. Negative 6. Awesome. Very good. Negative 6. All right. Let's see the color. This is the blue. Going to the blue. It's green actually, sorry. This is green. And then do the blue. You'll see the diagonal pattern again here. And you do pink. And you do yellow. Right, you see the same color. By the way, this 93 is not thing. 93 is outside color. this blue only has x cubed. Blue here. Oh, that's green. Oh, my bad. I'm sorry. It's green. This green only have x cubed, by the way. Only the terms in the box. We only consider. Now we are done with the whatever outside the box. We only consider the terms inside the box. So follow the pattern. The green gives us x cubed. The blue, you see the two terms on the blue, they are like terms, right? Negative x squared, negative 3x squared, they should add up negative 4x squared. Negative 4x squared. And the two terms on the pink, they are also like terms. 2x plus 3x, 5x. And then the yellow, one term in the yellow, negative 6. And that's the result. That's the multiplication. X cubed minus 4x squared plus 5x minus 6. Do you like the box method? I really like it. Once I know this method, I'm not using other methods. Maybe. Very good. Thank you, Joe. So this is how do we multiply a trinomial by a binomial. We can use the box method. Of course, you can use distributed repeated distribution method. You can do this. 1, 2, 3, 4, 5, 6. You have 6 terms in the expansion. And you simplify the 6 terms and then combine the like terms. Okay, let me show you some pattern when it comes to multiplying two polynomials, okay? First pattern, monomial times monomial. Monomial has one term. Another monomial has one term. 1 times 1 equals 1. So the expansion also has one term. 1 times 1 is one term. When we multiply a monomial by a trinomial, monomial has one term. Trinomial has 3 terms. 1 times 3 is 3. So the expansion, this is the multiplication expansion, has 3 terms. 1, 2, 3. When we multiply two binomials, this binomial has 2 terms. Second binomial has 2 terms. 2 times 3 is 4. So the expansion has 4 terms. FOIL. 4 terms. Before we combine like terms, it has 4 terms. And then when we multiply a trinomial by a binomial, trinomial has 3 terms, binomial has 2 terms. 3 times 2 is 6. So in the expansion, in the box, we have 6 terms. In the expansion, we have 6 terms. So that is one pattern I want to show you. For example, if we have a trinomial, for example, x squared minus x plus 1 times x cubed minus 5x squared plus 9x plus 10. If we are multiplying a trinomial by a polynomial with 4 terms, and you need to know trinomial has 3 terms, that second polynomial has 4 terms, 3 times 4 is 12. You are expecting to have 12 terms in the expansion, and then you combine the 12 terms in the expansion. Do you see what I'm talking about here? That's the first pattern. You need to determine, when you multiply two polynomials, you have to first determine how many terms in the expansion. Okay, second pattern. Let me show you the second pattern from the monomial times monomial. Where is it? Oh, it is here. Look at this monomial. Tell me what's the degree. What's the degree of the monomial? And what's the degree of this monomial? Let me change the color. Use the green. The first monomial degree is 2. Second monomial degree is 3. 2 plus 3 is 5. So the result is degree 5. Okay? When we multiply two polynomials, if the first polynomial degree is 2, second polynomial degree is 3, then your answer must have a degree 5. If it's not, that means your answer is wrong. Let's see this monomial times trinomial. The monomial degree 2, right? 9x degree 2. And the trinomial degree 3. 2 plus 3, 5. So the answer must be a polynomial with degree 5, and it is. Look at here, degree 5. If it's not, that means your answer is wrong. Look at the binomial times binomial. The first binomial, degree 1. Second binomial, 5x plus 1, degree 1 as well. 1 plus 1 is 2. That means the result must be a polynomial with degree 2, and it is degree 2. 20x squared minus 11x minus 3 is degree 2, right? And the last question, the trinomial degree is 2. The binomial has degree 1. 2 plus 1 is 3. The result must have degree 3, and it is degree 3. Do you see that? My question here is, when we multiply this one, we're looking at it here. Tell me the result. So multiply a trinomial by a polynomial with 4 terms. This question, the result is a polynomial as well. What's the degree of the polynomial? What's the degree of the product of the two polynomials? 5. Awesome. So that means you understand, you see what I'm trying to show you. Two patterns. Those two patterns can help us to keep track and we are doing the right thing, especially the degree. All right. This is supposed to be for you to practice. I give you 5 minutes. Let's do the first one first. The first one give you 2 minutes. X plus y times x minus y. Use the box method. I would like you to try the box method, okay? X plus y times x minus y. You're going to have a 2 by 2 box. How do you fill in the 4 cells? You should have the diagonal pattern. I'll give you 2 minutes and now show my result. X plus y times x minus y. 1 more minute. X squared, be careful with the sign. Be careful with the sign. Let me show you. I'm going to use my OneNote. I have more space. The first question, x squared x plus y times x minus y. So make a box, 2 by 2 box, x plus y, x minus y. So I have x times x, x squared, x times negative y, negative xy. X times y, or y times x, same thing, x times y. And right here, we should have a y times negative y. We should have a negative y squared, right? And we do the color scheme. We do the color scheme. And this green and the pink on the diagonal, and the yellow, this diagonal, only one term. And notice the two pink, they happen to be, they are like terms. Not only they are like terms, they happen to be opposite. Do you see that? Negative xy, positive xy, they cancel each other. So we only have green and yellow left. That gives us the result, x squared minus y squared. Right? So the answer is x squared. Yeah, minus y squared. Perfect. X squared minus y squared. So this is x squared minus y squared. Very good. Keep going. Second question, I'll give you 2 minutes. Second question is x plus y to the power of 2. X plus y to the power of 2 is actually x plus y times itself x plus y. Try the box method again. X plus y is raised to the power of 2 is equal to x plus y times x plus y. Use the box method. We have x plus y, and let me know what you have. Please share your answer. What's your answer here for this one? X times x, x squared. X times y, x times y, y times y, y squared. And do the color again. So the green is x squared. The two pink, they cancel in this case. It canceled in the previous case, but not this one. We combine them, xy plus xy. We have 2xy. And the yellow is y squared. This is the answer, okay? X squared plus 2xy plus y squared. Let me write it down. We have x squared plus 2xy plus y squared. And now please try number 3. Number 3, we have x minus y to the power of 2. X minus y to the power of 2. And it is x minus y times x minus y. Try the box method. X minus y, x minus y. x squared minus 2xy plus y squared. Awesome. Thank you, Amanda. That's correct. Similar with earlier, right? X times x, x squared here. X times negative y. X times negative y is negative xy. Negative y times x. Negative y times x is the same with negative x times y. So it's also negative xy. And in this cell, negative y times negative y gives us a positive y squared. Negative times negative is positive. And the color scheme is the same thing. Yellow, pink, green. The green is x squared. The two pink combined together gives us 2 negative x times y. So it's negative 2xy. Negative xy minus xy, we got a negative 2xy. And then the yellow y squared. So let me write down the answer here. We have x squared minus 2xy plus y squared. So if you don't have the same thing, double check your solution to see what went wrong. Now please try number 4. I can write number 4 here, and we have more space. Number 4 is a binomial times a trinomial. Let me double check. Yeah. The binomial is x plus y. The trinomial is x squared minus xy plus y squared. Trust me, do a flat box. Instead of doing a box look like that, doing a flat box, all right? So then you're gonna put the trinomial on the top, x squared minus xy, y squared, and the binomial on the side, x, y. Let's see what you have. X cubed plus y cubed, that's correct. Very good. Let's see how do we end up with x cubed plus y cubed. Row 1, column 1, x times x squared, x cubed. Row 1, column 2, x times negative xy. Positive times negative, negative. And you have 2x together, so x squared, and 1y. And in this cell, you have row 1, column 3, you have x times y squared. Row 2, column 1, we have y times x squared. Y times x squared is the same with x squared times y. Be flexible here, okay? And then in this cell, row 2, column 2, positive times negative, we have a negative. Y times x times y, we have 2 y's, so y squared, 1x, so negative xy squared. The last cell, y times y squared, y cubed. Let me show you the color. Green, pink, purple this time, purple, and yellow. The result has x cubed from the green. Look at the two pink. Do you see the two pinks are like terms? Not only they are like terms, they also are opposites. X squared y, the other is a negative x squared y. So they add up to 0. They cancel. They add up to 0. And the two purples, the same thing. Xy squared and the negative xy squared, they cancel as well. And the yellow, so plus y cubed. And that's the answer. Okay? Let me write down the answer here. x cubed plus y cubed. X cubed plus y cubed. You are too fast, Amanda, but I was there too. Perfect. Very good. Last one. Okay, racing starts. We have x minus y times x squared plus xy plus y squared. A binomial times a trinomial. X minus y is a binomial. X squared plus xy plus y squared is a trinomial. We want a flat, stable box. So put the trinomial on the top, put the binomial on the side. Okay, let's see who's the first. Amanda. X cubed minus y cubed, that's correct. Very good. Is x cubed minus y cubed. So row 1, column 1, x times x squared, x cubed. Row 1, column 2, x times xy, x times x times y, so x squared y. Row 1, column 3, x times y squared. Row 2, column 1, negative times positive is negative, so negative x squared y. Row 2, column 2, also negative. We have y times x times y, so 1x, 2y's. 2y's multiplied together gives us y squared. And last cell, negative times positive is negative. Y times y squared, 3y's multiplied together, y cubed. Let me color them. This is the yellow. This is the purple. And this is the, sorry, this is pink. This is the purple. And this is the green. The green gives us x cubed. The pink cancel each other. I hope you see that. The purple also cancel each other. The two terms are opposite. And then we have one more left, one term left, the yellow, is negative y cubed. So the answer is x cubed minus y cubed. X cubed minus y cubed. So if you have not finished all the 5 questions yet, I would strongly recommend you you complete them later on your own. And this is the answer. And those 5 questions are very important. The reason they are important is because they are special product. They are special product. And not only we need those 5 equations, they actually are 5 important formulas. But also we needed them in chapter 6. So chapter 5, we needed those 5 formulas. We actually just proved the 5 formulas. And we needed those formulas for special product in chapter 6. And we needed those formulas again for what reason? For special factoring. For special factoring. Same 5 formulas. Same 5 equations. So let me explain the names for each formula. Okay, the name would help us to memorize the formula. The first formula, x plus y times x minus y equals x squared minus y squared. We call x plus y and x minus y as a conjugate. Okay, we call x plus y and x minus y the two binomials as a conjugate of each other. Similar ways, if we have star plus triangle, the conjugate of that would be star minus triangle. The two items are the same, star and triangle. The only difference is the operation between them. This is adding, this is subtracting. If we have two binomials, they are conjugate of each other, then the result is also going to be a binomial. And that binomial has a special structure. This binomial is a what? Is a difference of two squares. I need you to take notes here. X squared minus y squared is a difference of two squares. The name of it describes the structure of the expression. It's a difference because x squared minus y squared is a subtraction. And the two things subtracted, the two things in the subtraction, they are squares. X squared minus y squared. If we have star plus triangle, multiply with its conjugate, star minus triangle, star plus triangle times star minus triangle, then the result is going to be a difference of two squares. Difference of two squares. It's going to be the star square minus triangle square. That's how does it work. So if you remember this formula, then you would be able to process the multiplication faster. But even you don't remember the formula, you still could just use the box method to find the answer very quickly. But I hope for the sake of chapter 6, and you should memorize the formula. Okay? Is more important, those formulas are more important for chapter 6. I want you please remember those formulas. In chapter 5 is because you just proved them. You just proved this formula. When it's still fresh, you still understand why, and you memorize what. What is this formula look like? What's the name of the formula? The name of the formula is difference of two squares. If we have two binomials multiplied together, and those two binomials are conjugate of each other, then the result is going to be a difference of two squares. That's the first formula. Second formula, x plus y to the power of 2 gives us x squared plus 2xy plus y squared. And we have a name for each side, for each expression on the expression on each side of the equation, the formula. This is a x plus y to the power 2. This is a square of binomial sum. This is something you need to take a note, including your notebook. This is the square, the structure of this expression. It is a square of binomial sum. Square on the shoulder of the parentheses. The base is a binomial, and the binomial is an addition, two terms added together. So square of a binomial sum. Yeah, I hope you remember the name of this expression. It is a square of binomial sum. Turns out a square of binomial sum is a what? Is a perfect square trinomial. Perfect square trinomial. Sorry, what is a perfect square trinomial look like? Firstly, it is a trinomial, right? 1, 2, 3, three terms. Perfect square trinomial has the first term and the last term. Both of them are squares. Let me highlight. Let's use yellow this time. This is a perfect square. This is a perfect square as well. And the first perfect square has base x, and the second perfect square has base y. And in the middle, it happens to be twice of the product of the two bases. Very, very symmetric. Why? Because you just proved, right? Yeah, Amanda just proved them. It's right here. We just proved them. So when you still understand why x plus y to the power 2 equal to x squared plus 2xy plus y squared, I want you please memorize. Remember the name and memorize it. When you have a square binomial sum, the result is a perfect square trinomial. The middle term is a positive 2xy, twice of the multiplication of two bases. Are you okay? Am I clear what I'm talking about? Or I lost you? Are you still with me here? I'm explaining the special looks of those formulas. Okay, thank you. Next, number 3. Number 3, this formula is x minus y to the power of 2 equals x squared minus 2xy plus y squared. About why do we have this formula? You just prove it. You just proved x minus y to the power 2 equals x squared minus 2xy plus y squared. If you have a question, you can ask Amanda and Jill, all right? Okay, so to help us to memorize this formula, you want to remember the structure, the name of the expression. The left side is a square. We call this square of binomial difference. It's a square on the shoulder of the parentheses. The base in the parentheses is a binomial. And between the two items, like x and y, we call them items just for the convenience of description. We have a subtraction. So we call x minus y as a binomial difference. It's a difference, x minus y. So we call this a square of a binomial difference. Turns out the square of binomial difference is also a perfect trinomial. This is a perfect square trinomial. The only difference, the pattern, the only difference is the middle term is not positive anymore, it's negative. Okay? The square of binomial sum is a perfect square trinomial with the middle term positive. Square of a binomial difference is also a perfect square trinomial with the middle term, the green one, negative. So you can see the result on the right side. The first term is a square of x. The last term is a square of y. In the middle, the green is a negative twice of the multiplication of the two bases x and y. So remember the pattern, okay? Remember, very symmetric, very symmetric. I really enjoy this as the beauty of mathematics. Those formulas, many people are just hate those formulas. I like them because they're so symmetric, and I like those patterns. So that's number 3. Number 4 is x plus y. Oh, I'm gonna use red color. X plus y times x squared minus xy plus y squared. The result turns out is a binomial x cubed plus y cubed. And we call this binomial sum of two cubes. Sum of two cubes. The two bases of the two cubes are x and y. So on the left side, we have a binomial times a trinomial. The binomial simply is the sum of the two bases. And the trinomial also has a pretty special looks. And the first term is the square of the first base. And the third term is the square of the second base. And in the middle, we have a negative minus the multiplication of two bases. It takes memorization. I hope the name could help a little bit. Number 5 is number 4. I would recommend that you memorize number 4 and number 5 together. So x minus y times x squared plus xy plus y squared. Yeah, notice how do I change the sign? This is a plus, this is a minus. This is minus, this is plus. This is a plus, and you know on the right side we're going to have minus x squared, x cubed minus y cubed. This is minus. And on the right side, the binomial is a difference of 2 cubes. As I said, when you still understand why we have those formulas, why those formulas are correct, we just prove them, right, using the box method. When you still understand why, I strongly recommend you memorize those formulas. For the sake of chapter 6. If you memorize those formulas, when we go to chapter 6, your job is gonna be a lot easier. All right, guys. But if you don't remember those formulas, you will be fine in this chapter. Worst case, you just use the box method, right? It seriously doesn't take too much time. But for chapter 6, you really have to remember those formulas. Okay, so that's everything about multiplication of polynomials. Oops, we're running out of time. We have 15 minutes. 15 minutes, we are going to try to cover division of polynomials. Okay, division of polynomials. I'm going to move this question some other places. Division of polynomials. 2 types of problems. The first type, talking about division. The two polynomials play default. And let me explain. When we divide a by b, okay, a is called dividend. B is called divisor. They have different names. They play different roles. The reason we have to differentiate them is because division does not satisfy commutative property. For example, if we have 4 and 2, divide 4 by 2, we have 2. But if we switch the order of the two numbers in the division, if we divide 2 by 4, you should have 0.5. The result is different. It's not like a multiplication. Multiplication satisfies commutative property. 4 times 2, 2 times 4, they both equal to 8. So you can switch the order of the numbers in the multiplication, doesn't matter. You don't have to worry about that. But you're going to be very careful not to randomly switch the order in a division. That's the reason we need to differentiate the two quantities in a division. They have different names, would help us to remember the role they play. The first number is called dividend. The second number is called divisor. And we could rewrite division as in the fraction quotient format. So a divided by b can be written as a over b. So we know the numerator is going to be the dividend. Numerator is the dividend. Denominator is the divisor. Okay? Yeah, please take time to memorize in a division which part is the dividend, which part is the divisor. Numerator is the dividend. Denominator is the divisor. And here we are going to learn how do we divide two polynomials when the divisor is a monomial. So here we are going to talk about dividing a polynomial by a monomial. This case is a simple case. The regular case, when the divisor is not monomial, is more complicated. We probably don't have time to cover that today, because if the divisor is not a monomial, we're gonna learn the long division, and to explain a long division problem, I need at least 20 minutes. So we are not gonna cover that today, but we are going to cover how do we divide a polynomial by a monomial. We are going to talk about how do we divide two polynomials when the divisor is a monomial. For example, this case. Numerator is a polynomial, is a trinomial specifically. 24x fourth minus 8x squared plus 20x. And the denominator 4x is a monomial. So this is the case we're covering today. Okay, so how do we divide a polynomial by a monomial? We have a formula, and I call it a formula. Technically it's not, but I call that as a formula, or you can see that as a rule. Here, let me derive the rule for you. Look at here, 1 plus a, 1 over a plus 2 over a plus 3 over a. How do we add 1 over a plus 2 over a plus 3 over a? What do we have? What is 1 plus a? Sorry, what is 1 over a plus 2 over a plus 3 over a? When we add fractions with the same denominator, we keep the denominator, solve the top, right? When we add up fractions with the same bottom, we keep the bottom, solve the top. So do you agree we have 1 plus 2 plus 3 all over 8? Yeah, I know it's gonna be 6 over 8 and a quarter, 3/4. Sorry. Yeah, perfect. So if you agree this is a true statement, and you should also agree this statement. What is statement? 1 plus 2 plus 3 all over 8 equals 1 over 8 plus 2 over 8 plus 3 over 8. Because they are same equation, right? All I just did is to switch the sides of the equation. I read the right side as left side as right side. If the first equation you agree with it, then you should agree with the second equation as well. And the second equation is the rule I want you to remember, because we are going to apply the rule to divide a polynomial by a monomial. So here, how do I understand this rule? When we have 3 terms on the top, let me highlight, then you'll know what I'm talking about. So look at here. When we have 3 terms on the top, term 1, term 2, term 3, and 1 term on the bottom, we are able to write that division as an addition. We are going to use term 1 on the top, in the top divided by the bottom, plus term 2 in the top divided by the bottom, plus term 3 in the top divided by the bottom. Let me know, do you see what I'm talking about here? That's the rule we are going to apply. How do we divide a polynomial by a monomial? Use each term in the top divided by the bottom and then add them together. Okay, perfect. Thank you, Joe. Then let's apply it. The numerator is the dividend. The dividend has 3 terms. Oh, Dakota already have the answer. I need to do it first. Give me 1 second. So we are going to use the first term in the numerator to over the monomial on the bottom, the divisor, plus I always use adding. I don't use minus, okay? You please also use adding. Second term in the top. Second term in the top is negative. So please do not just get rid of the negative sign without a reason. You don't get rid of it. You keep it. Second term in the numerator is negative. negative ax squared divided by the bottom for x, plus the third term in the top in the numerator, 20x divided by the bottom. We got that by using the rule in the red box. And then simplify each part in a step. Do not do multiple steps in one, okay? Unless you are very, very good at it. Okay, so let's simplify. Using what? Using quotient rule, if you still remember. Quotient rule, okay? 24 over 4, 6. X fourth over x cubed. How do you know it's x cubed? You either use the quotient rule or you understand this way, okay? X to the power of fourth means you have x times x times x times x. Denominator is 1x. Cancel 1x. Denominator has no x. Numerator has 3x. So you have x cubed. And those things we covered already in previous sections. And the second part is actually a term as well. Second term here. Numerator is negative. Denominator is positive. So that part is going to be negative. 8 divided by 4 is 2. X squared over x is 1x. Numerator has 2 x's, denominator has 1. So the 1x in the denominator is going to be cancelled. We have 1 extra x on the top. And in the third part, positive 20 over 4, 5. X cancel x. And there we go. That's it. I didn't keep the x in the bottom in mind. I didn't keep the x in the bottom. Keep. The coda is right. Yeah. Okay. I'll have to keep practicing. Yeah, practice this one. Practice this problem. Hands-on practice is very important. Just like you watch people practicing playing game football, you see that pretty or basketball, you know very well, but it doesn't mean you can you understand that basketball doesn't mean you can play in a court, right, very well. It takes time. It takes tons of practice. Okay, try this one, please. Firstly, please rewrite the division as a quotient. Will make your job easier. Write a dividend on the top. Write a divisor on the bottom. Okay. We have 4 minutes left. Give you 2 minutes. Give you 2 minutes. Okay, let me double check. Let me do it first. First term on the top over the bottom plus second term, which is negative, on the top over bottom plus third term on the top over the bottom. And let's simplify. 27 over 3, 9. X eighth over x cubed, x fifth. Second part is negative 5x cubed. 6 minus 3 is 3. This 9 over 3 is 3. X cubed cancel x cubed. So 9x fifth minus 5x cubed plus 3. I think you guys doing great. Yeah, plus 3. You guys doing great. Very good. So that's the division. We finished 3 minutes earlier. That's how do we divide a polynomial by a monomial. Then what if the divisor is not a monomial? Then the problem is going to be a lot more complicated. The method we're going to learn to divide a polynomial by a to divide two polynomials with the divisor not a monomial is called is called long division. So we're gonna talk about long division on Monday. Let's look at the syllabus. Today is Wednesday, right? Yeah. So we have one thing left over, did not cover. We're gonna cover on April 8th. So I'm trying to say is next week we are going to start a review, but I will keep the exam open. So if you want to take it earlier, you can take it from April 8th. So the time you can take the exam 2 is those 2 weeks. Okay. This next
Could you
week or
repeat
the
those
week
2
after.
weeks? I'm so sorry. My phone somehow muted and I don't know what happened, but I didn't hear those 2 weeks.
Don't worry about that. I will post an announcement in Blackboard. So next week we review, but I will keep the exam open next week. And the week after, I will also keep the exam window open. So you have 2 week time period that you can take your exam to in the testing center. So basically, it's gonna be from April 8th all the way to 20th. I will include both Saturdays in case you cannot make it on weekdays. All right, from April 8th all the way to April 20th. I will, once I have the paperwork ready, I will post the announcement and remind you through email to read the announcement. All right, guys? And that's for today. We're going to cover long division next time. Do we have to do the practice exams? Will they count against us if we don't do them? The practice exam is graded into your course total. If we look at the syllabus, sorry, my English is really bad today. I'm not really, I apologize for that. So the syllabus talk about answers question here. Joe, look at here. Quiz category. In a quiz category, we have 5 quizzes and 3 exam practices. Together we have hold on. Find 4 practice. So together we have 9 items here, and they are equal weighted into the quiz category. Each item accounts for 2.2%, and you have 3 attempts for quizzes, but unlimited attempts for practice test. It doesn't matter. It is graded. Okay. All right, guys. I'll see you on Monday. Have a great weekend. If you have any further question, please email me. Good night.